P6 Rational Expressions Day 3. Your learning goal is that you will be able to add, subtract, and simplify complex rational expressions. Example 1, we're going to add or subtract as indicated. So let's first start with addition. And just to remind you, when you add or subtract, you have to have common denominators. And sometimes it's helpful to factor the denominators first. Don't worry about the numerators yet. 2 factors of -6 that add to give you -1. So it would be -3 and +2. And on the right side, if you notice, it's the exact same thing. Okay, so the denominators are the same, right? Same denominators. So that means that we can keep our denominator. And then we're just going to add and combine like terms. So x squared, we have nothing to add with this. -4x and +4x cancel each other out, and then we just have the -4. And what we do from here is we simplify like in the previous section. So this numerator will be x plus 2, x minus 2, x minus 3, x plus 2. And then make sure you restrict your values for x. So x can't be 3 or -2. And then you divide if you can. So these two can divide. And so you're left with x minus 2 over x minus 3 with these restrictions. Example 1b. First thing you want to do is see if we can factor the denominators so we can see if the denominators are the same. Okay, notice our denominators are not the same. This one has 2 factors and this one only has 1. So this one needs an x plus 2. And whatever you do to the bottom, you have to do to the top. So now I have the same denominators. Before you do anything, anytime you have multiplication, you have to multiply first. So I'm going to FOIL these 2 factors. I'm going to put them in parentheses because I still have to subtract. X squared plus 2x plus 1x gives me plus 3x plus 2. I still have my x plus 5 all over my common denominator. And it doesn't matter the order. Alright, so now we are subtracting. So that means this subtraction has to go for each term. So I'm going to write them in descending order. So I have -x squared. 1x minus 3x is -2x. And then 5 minus 2 is 3. Okay, we can't factor the numerator. Let's make sure. But take out a -1. Actually, we probably could if I took out a -1. And that will leave us with x plus 3, x minus 1. But if you notice in this case, we can't divide anything. So that's as simple as we can go. And then just make sure you do your restrictions. X cannot equal -2 and 2. So you can either leave it as this answer, or it can be in factor form like this. So both of these answers are correct. Example 2. Now we're going to be simplifying each complex rational expression. Basically, a complex rational expression means that you have more than one fraction. Your numerators or your denominators contain one or more rational expressions. So if you look at the top, this is over 1. This is over 1. The top has 2 fractions and the bottom one has 1. So you see 1, 2. So it's 3 fractions altogether. So what I'm going to do first is work with the numerator and get a common denominator. So this one has a 4 and this one is a 1. So we're going to have to multiply top and bottom by 4. And that will give us x over 4 minus 4 over 4. And the bottom denominator is okay because it's already 1 fraction. And that leads us to x minus 4. We can't really do over 4 because that's our common denominator, divided by x minus 4 over 1. So now we have a division problem. I'm going to write it like this, so it can look like the previous lesson. So we're going to do keep, change, flip, or multiply by the reciprocal. So keep, change is the multiplication, and flip. And if you notice, these two factors divide to equal 1, so your answer is 1/4. Now, our restrictions come from any variable that was in the denominator. So, nothing on the top. Here, what value of x will make this 0? And that would have to be 4, so we have to exclude 4. Okay, B. Same thing. I'm going to put everything over 1. That doesn't have a denominator. So I'm going to work with the numerator first. I want to get a common denominator. This one has a 1 and this one has an x. So I'm going to multiply top and bottom by x. So that leaves me with 8x plus 1 over x. Same thing on the bottom. This one has an x. This one has an x. So that leaves me with 4x minus 1 over x. And then, once you have 1 fraction in the top, 1 in the bottom, you write it like a division problem, horizontally instead of vertically. And you're going to do keep, change, flip. So keep the first one, change the multiplication, and flip the second one. So x divided by x is 1, so you're left with 8x plus 1 over 4x minus 1. And you can divide that because we don't know what x is. All right, your restrictions. Let's see, where did we have a variable in the denominator? We have one here, here. These two were already counted for. All right, so x cannot equal, on all these places where it's just x by itself, that would be 0. Then you have this one, 4x minus 1. If you don't know what x has to be, you can always set it equal to 0. So that would be 1/4. So x can't be 0 or 1/4. Okay, last one. So the first thing I do, remember, is I make sure all my fractions have denominators. And then I'm going to work with the top to get one fraction. So this denominator has x minus 2. The second one needs 1. Whatever you do to the bottom, you have to do to the top. So I'm left with x plus, I'm going to just distribute the 1, x minus 2 all over x minus 2. Divided by, this one is x plus 2, x minus 2. So this denominator needs the exact same thing. Alright, so my numerator I have 3 plus, FOIL these first, then multiply by 1, which is itself. X squared minus 4 all over. And keep your denominator like it is in factor form. Alright, so we can combine. That'll be 2x minus 2 over x minus 2 divided by x squared minus 1 over x plus 2, x minus 2. So let's write it over here like a division problem. Divided by alright, so we're going to do keep, change, flip. And then, sorry, I meant to tell you that I factored the numerator. I need to factor this side, so I'm going to take out a GCF, which is 2. Alright, let's do our restrictions. X cannot equal, so anything that was in the denominator that would make any value of x that would make your denominator 0. So we have 1 here, we have 2 here. Same one, same one, same one. We have, so x can't be positive 2, negative 2, negative 1, positive 1. And then you divide what you can. Oh, I wrote this wrong. Sorry. Alright, and then you're left with 2, x plus 2 over x plus 1. With those restrictions. And there you have it.